All right, so this is the start of section 7.5, and this is the last section of the chapter. We're going to talk a lot about trapezoids and kites and all the property that comes along with those two. So before we really get started, we need to go over some vocab. So a trapezoid is a quadrilateral with exactly one pair of parallel sides. Okay, it has only one pair of parallel sides. It does not have two pairs of parallel sides. So in other words, a trapezoid is not a parallelogram. Okay, it only has one set of parallel sides. Now notice here's kind of the anatomy of an isosceles trapezoids. The two sides that are parallel are called the bases, and then the other two sides are called the legs. All of these are called base angles, but notice that the base angles come in pairs. Okay, so think of base angles as the angles along the same base. It's like another name to say base angles. Now, an isosceles trapezoid is a trapezoid with congruent legs. So a lot of these stereotypical trapezoids that look like here and here, that look like this would be an isosceles trapezoid. These two would be parallel, but then these sides here, the legs, would be congruent. And a lot of the special properties of trapezoids are for isosceles trapezoid. A right trapezoid is a trapezoid with exactly two right angles. So that would look like this. Okay, that's not a very good trapezoid, guys. Let's try that again. So it looked like this. There we go, that's better. So this side and this side would be parallel, and then this and this would be a right angle. Okay, that's what a right trapezoid would look like. All right, last but not least, we have the kite. Now, a kite is a quadrilateral that has two pairs of adjacent congruent sides. But opposite sides are not congruent. Okay, so two pairs of sides that are side by side. So if I draw this, so like this side and this side would be congruent, and this side and this side would be congruent. But opposite sides are not congruent. And because opposite sides are not congruent, I know that kites are not parallelograms. And I'm going to abbreviate that. All right. So here's example one, and this is kind of just, do you know the vocab, what trapezoid is and what an isosceles trapezoid is. So we're given in this coordinate grid the plot of what appears to be a trapezoid, okay? Now clearly this is going straight up and down, and this is going diagonal, so these two sides, RO and ST, are not parallel. So what I want to say, or what I want to, I guess, check, is RS parallel, and I'm going to put a question mark because I don't know, to OT. Because if it is, then this is a trapezoid. If it's not, then it is not a trapezoid. So we do that just by finding the slope. Remember, you can tell if something is parallel or not by whether or not they have the same slope. And we can do this just by counting. So I'm going to say the slope of RS equals, and then the slope of OT equals. Okay, slope of RS, so I'm going up 1 over 1, 2. So the slope of RS is 1 over 2. Okay, the slope of OT is up 1, 2 over 1, 2, 3, 4. So the slope of OT is 2, 4, which then reduces to 1/2. So because these have the same slope, we do know that they are parallel, and so yes, this is a trapezoid. We've just shown that this is a trapezoid. Okay, now we want to ask, is this an isosceles trapezoid? So basically, is this here the same length as this here? And it looks like it could be, but it's kind of hard to tell. Okay, so we know that RO is 1, 2, 3 units. Okay, now remember, if this is a diagonal, we cannot just count boxes. This is not 2 units, okay? So we actually have to do the distance formula for ST. Now, if these come to be the same length, then it is an isosceles trapezoid. If it doesn't, it's not. So to do the distance formula, I would say 4 minus 2, and square that, plus 2 minus 4 squared, which reduces 2. Well, 4 minus 2 is 2, so 2 squared plus 2 minus 4 is negative 2 squared. 2 squared is 4, plus negative 2 times negative 2 is a positive 4. Remember, that's a plus 4, which is the square root of 8, which is not equal to 3. It's close. If this is the square root of 9, it'd be the same. But it's the square root of 8, so because of this, I can say not isosceles trapezoid. All right, so there's some theorems we can use with an isosceles trapezoid. Now, I do want to point out that these are all specific to isosceles trapezoids, not just trapezoids. They have to be isosceles for these theorems to hold true. Okay, so this first one, the isosceles trapezoid base angles theorem, tells us if a trapezoid is isosceles, then each pair of base angles is congruent. So I like to just say angles along the same base. Remember, base are the two parallel sides. Angles along the same base are congruent. Those are a little easier terms to understand. So notice in this, if BC is parallel to AD, that means angle B and C, these are angles along the same base, because this is a base, are congruent. And then angle A and angle D are congruent, but these two are not congruent. Notice these are obtuse and these are acute, and that'll always be true for an isosceles trapezoid too. All right, so the next theorem, it says if a trapezoid has a pair of congruent base angles, then it is isosceles trapezoid. So here we know it's kind of like an isosceles triangle. If angles along the same base, now this is the base and this is the base because they're the two parallel sides. If these two angles are congruent, that means these two sides are congruent. And if those two sides are congruent, then it would be an isosceles trapezoid. Okay, last but not least, the diagonals theorem, isosceles trapezoid diagonals theorem. If a trapezoid is isosceles, or a trapezoid is isosceles, if and only if its diagonals are congruent. So if it's an isosceles, then AC here is going to be congruent to BD. The diagonals, so this is going to be congruent to this. All right, let's look at example 2 now. So it says the stone above the arch in the diagram is an isosceles trapezoid. Find the measure of angle K, the measure of angle M, and the measure of angle J. All right, so we know this is an isosceles trapezoid and we know this is 85 degrees. So angles along the same base are congruent. And because this side and this side are parallel, we know this is a base and we know this is a base, which means that angle K has to equal 85 degrees. So this is 85 degrees. Okay? Angles along the same base are congruent. Now let's think of this. Okay? We know KL and JM are parallel. Okay? If I have a transversal that goes through here, then this angle and this angle would be consecutive interior angles. And what do we remember from chapter 3 about consecutive interior angles? What is their relationship? Hopefully you remembered that consecutive interior angles are supplementary. Okay, So this and this are consecutive interior, so they are supplementary. So 180 minus 85 would be 95 degrees. And then once again, angles along the same base are equal, so this would be 95 as well. So I can say angle J is congruent to angle M, which equals 95 degrees. All right, let's look at example 3 now. It says if EG, and EG is here, is equal to FH, which is here, is the trapezoid isosceles. So these two are the diagonals of a trapezoid. Now, what do we know is true about the diagonals of an isosceles trapezoid? All right, so the isosceles trapezoid diagonals theorem told us that a trapezoid is isosceles if and only if the diagonals are congruent. So this would be a big fat yes by the isosceles trapezoid diagonals theorem. Guys, I'm abbreviating like crazy here. All right, well, now it says if angle HEF, so if this angle here is 70 degrees, and FGH, this angle here is 110, is it isosceles? Okay, well, let's think about this. We know that this line here and this line here are parallel, okay? Which means that this angle and this angle are consecutive interior angles which are supplementary. So if they're supplementary, that means this has to be 70 degrees. Okay, well now if I compare angle E and angle F, I see that angle E is congruent to angle F, so the angles along the same base are congruent. And the isosceles trapezoid base angle converse theorem tells us that if angles along the same base are congruent, the opposite sides are congruent, so it is an isosceles trapezoid. So this would be a yes by the isosceles trapezoid base angles converse theorem. All right, let's talk about the mid-segment of the trapezoid now. Okay, so the mid-segment, let's define it first. So in this diagram, this would be the mid-segment, and we can find the mid-segment of a trapezoid by connecting the midpoints of the legs. Okay, so M is the midpoint of AD, and N is the midpoint of BC. Okay, and what is unique or, I don't know, crazy about the mid-segment of a trapezoid is the mid-segment is the average of the two bases. Remember, in this case, AB would be a base and DC would be a base. All right, so example 4, it wants us to find the mid-segment length here. Okay, and we know it's a mid-segment because we can tell this is the midpoint, and then we can tell N is the midpoint as well. So the mid-segment's going to be the average of the two bases, which is 12 and 28. So to find the average, 12 plus 28 divided by 2, well, 12 plus 28 is 40. 40 over 2 is 20 inches. That would be the length of the mid-segment. All right, so what you know about mid-segments and the definition and how you find it, I want you to go ahead and do example 5 on your own, and then we'll go over it. Do note that there are more than one way to do this. All right, so after you've gone through and done the math, regardless of which method you should have done it, you should have gotten roughly 6.7 units. Now what I did is I went and found the midpoint of ST to get the coordinates of Y, same thing here to get the coordinates of Z, and then did the midpoint. Or you could have just done the distance formula several times, SV to TU, and then found the average of those, and that would have gotten you the length of YZ as well.